Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing solving rational equations. So when we think of rational equations, we're just thinking of fractions with polynomials in the numerator and denominator. And the way that we solve problems like these, so like we have in 1, 2, and 3 for example, is we first want to factor the denominator completely. Then we find the LCD between all the denominators. And then the point of these and the solving method is to eliminate the denominator. Fractions are hard to deal with, so we eliminate it by multiplying through by the LCD. And we do this to each term of the LCD. Then, depending on the type of equation, you solve, and you're trying to get, usually if it's a quadratic, one side equal to 0, and go through those methods. And then, and this is not an option, you need to check your solutions. And it's mostly just to make sure that a denominator didn't become 0, because we can't divide by 0. When we're doing these problems, sometimes extraneous solutions pop up, and we make sure that we don't have those by checking it. All right, so, and again, to be clear, here checking, all this means is checking by plugging it into the denominator, making sure the denominator doesn't become 0. That would be what makes these problems not feasible, or rather the solution not feasible. So let's go through this. So we want to factor the denominator completely, so we're going to start with 1. And even though this is technically not, this is actually just a linear equation, but the fact that these have fractions, we're going to be able to look at this in one form so that we can apply this to the rational equations in the other two, in 2 and 3. So first, we're going to factor the denominator. So what can I factor 9 to be? Well, 9 is the same as 3 times 3. So 3 times 3. What's 6 factor into? Well, that's 2 times 3. And what does 4 factor into? Well, that's 2 times 2. Then we just have to find the LCD. Now the LCD for number 1, all we have to do is look at what, basically we need to, since to be able to add, subtract, or whatever, to have a common denominator, they must all have, everything must be in the LCD, right? So here, for example, we have 2 copies of 3. So 2 copies of 3 must be in the LCD. Here, so we look at this one. In this one, we have 1 copy of 2. So 2 must be in the LCD. And here, but we already have 1 copy of 3 because we have 2 copies of 3 in the LCD. So we're good. Here we have 2 copies of 2, so 2 copies of 2 must be in the LCD. Here we only have 1 copy, so we must add another. So the LCD is 2 times 2 times 3 times 3, which is 9 times 4, which is 36. But we're going to leave the LCD multiplied out to keep it more in line with what we would do here. When you deal with the LCD over here, you don't actually multiply it. So the next step is probably what most people consider the most annoying step. And that is to multiply every term. So this is a term, this is a term, and this is a term. We multiply each one of these by the LCD. So let's do that. So I'm going to come all the way over here. 2 times 2 times 3 times 3 times x over 3 times 3. And then 2 times 2 times 3 times 3. Times the next term, 5 over 2 times 3. And then lastly, 2 times 2 times 2 times 3, or 2 times 2 times 3 times 3, times x over 2 times 2. All right, so we're kind of butting into this problem over here, but thankfully it's going to get smaller really quickly. 3 times 3, so let's scoot this back over. 3 times 3, we have 2 copies of 3 here, we have 2 copies of 3 here, so they both cancel. And then 2 times 2, since there's nothing in the denominator, we just have 2 times 2, which is 4 times x, which is 4x. So you multiply everything times everything in here. So if there were multiple terms, you'd have to distribute the 4 to both of those terms, for example. Here we're canceling 1, 2, and 1, 3, so 1 copy of 2 and 1 copy of 3. And those are out of the denominator, so we just have 2 times 3, which is 6, times 5, which is 30. And then last we have 2 times 2 times 3 times 3, and then we're dividing by 2 times 2. So Both of those copies go away, so 3 times 3, which is 9, and then times x is 9x. So this problem becomes much nicer and much easier to deal with when we multiply through by the LCD. So the way we say this is that we're clearing the fractions by multiplying through by the LCD. Now we try to solve for x, so let's get all terms with x on one side. So I'm going to subtract 4x. We have 30 equals 9x minus 4x is 5x. And then we're just dividing, we're solving for x, so we're dividing by 5. And then x, so 30 divided by 5 is 6. So x equals 6. Now, is there a denominator here? Is there a variable in the denominator? No. Okay. So we don't have to check. Now, I say it's not optional. Again, it's only it's not optional if there's a variable in the denominator like there are here. Then we would have to check our answer. Okay, we're 100% have to. Because of that, we do not, though. And you'll see why on this next one, why it's so important. So let's try this next one. So we're going to try to factor the denominator completely. Well, x minus 3 and x minus 3, those are each terms. Those can't be factored, really. So x minus 3 is the only denominator that we have in both terms. So what is the LCD? Since it's the only denominator, x minus 3 is the LCD. That must be the case. So what we do is we multiply x minus 3 times the first term. So on one side, x squared over x minus 3. And we multiply x minus 3, I should put this in parentheses to be clear, times 9 over x minus 3. And then, this is the cool thing, this one wasn't too hard in this sense because the x minus 3's in both cancel. Remember, x minus 3, those are two terms, and we think about that as one factor in that sense. And we're left with just what's in the top. So both of these cancel, so we're left with just x squared, and we're left with what's just left in the top over here, which is 9. And we have x squared minus 9. Well, there's a couple ways to solve this problem. You could minus the 9 over and do this, but because it's x squared, we can just square root both sides. And when we get rid of the square and the square root, the right side should become a plus or minus. And what's plus or minus 9? Or what's the square root of 9, rather? The square root of 9 is 3. So we have two solutions, x equals 3 and x equals negative 3. And this is where it becomes important. Now here we have two solutions, but the denominators are x minus 3. So again, we really only need to check them into the denominators. So check. If I plug in 3 into x minus 3, so we have 3 minus 3, that's 0. Can we divide by 0? We cannot. So x equals 3 is not a solution. But what about negative 3? Well, we plug it in, and negative 3, so that's what we're plugging in, minus 3 is equal to negative 6. Can we divide by negative 6? Yes, we can. So x equals negative 3 is the only solution, while x equals positive 3 was not a solution. So the main idea for these problems is you clear the fraction. That's the main idea. So what about something like this? Well, this one's more complicated. All right, so let's try to tackle it. So first, we go through the steps, factor the denominator completely. We can't factor x plus 1. We just saw we can't factor x minus 3, so we shouldn't be able to factor x plus 3. And but we can factor this last one. So I'm going to rewrite this. So minus 2 over x plus 3 equals 4. So since there's no a, what are two numbers that multiply to be 3, that add to be 4? Well, 1 and 3. So x plus 1 times x plus 3. Now, what's the LCD? Well, again, the LCD isn't always as complicated as the one we did over here. How many denominators do we have here? We have x plus 1, so one factor. X plus 3 is one factor. Again, terms are our addition, subtraction. Factors are multiplication, so we have to consider the whole thing as a factor, since we can't separate that multiplicatively. So our LCD, it must have an x plus 1. Since that's what's in this denominator, it must have this factor, which is x plus 3. And then it must have each of these. Well, x plus 1 is already here, and x plus 3 is already here. So the LCD is x plus 1 times x plus 3. Oh, sorry. Okay, so we have both of those there. Then, what can we do? Well, just like we did here and there, we multiply every term. So we have 1, 2, 3 terms, and we multiply them by the LCD. So we're going to do that. X plus 1 times x plus 3. We're going to multiply that by, I'm going to put this in brackets just to be extra clear, x over x plus 1 minus, and then we have the next part, so again, multiply by the LCD, plus 1 x plus 3 times 2 over x plus 3 equals, again, lastly, we, again, 1, 2, 3 terms, all of them get multiplied by the LCD, x plus 1 times x plus 3, all times this last term, 4 over x plus 1 times x plus 3. And then we start the cancellation. So again, the whole point of this, the denominator should go away. They went away here, but that one was pretty simple. There was one denominator that shared the same denominator. And so x plus 1's cancel. X plus 3's cancel. And then here, x plus 1 cancels and an x plus 3 cancels. So are all the denominators canceled out? Yes, they are. So let's start this. So x, so we're going to rewrite this. It's x plus 3 times x. Before doing this, I'm going to take another step to multiply it. We have a minus and a 2 being so negative x plus 1 is multiplied by 2. So we can reorder this 2 times x plus 1 equals, again, everything canceled. We're just left with 4. So then x plus x squared distributes here. So we have x squared plus 3x. Here we have negative 2 distributing, so minus 2x minus 2. That's another good reason to reorganize this after, instead of just trying to multiply. Otherwise, you're thinking about distributing the negative and distributing the 2 if you try to do it all in one step. Equals, again, just 4. And now it's just a quadratic. So x squared, 3x minus 2x is plus x, minus 2 equals 4. Since it's a quadratic, probably get one side to 0. That one was 1, since we didn't have 2x terms, it was just 1x. We could just square root. But here we're going to probably get one side equal to 0. So plus x subtract 4. So we get minus 6 equals 0. Two numbers that multiply to be negative 6 that add to be positive 1. Well, x plus 3, so an x minus 2. Positive 3 times negative 2 is negative 6. Positive 3 and negative 2 add to be 1. And then we set each factor equal to 0. Then we have x equals negative 3 and x equals 2 as our solutions. But remember, this is only potential solutions. So we'd basically plug it into our LCD. So we got to check. Really, that's all you need to actually check against is the LCD. So we're going to check two things. We're going to check x equals negative 3. And does negative 3 plus 1 or negative 3 plus 3 equals 0? Well, we get negative 2 times 0. Negative 3 plus 3 is 0, and then equals 0. So x equals negative 3 is not a solution because it made a denominator 0. So again, or it made something in a denominator 0, right? So made at least one of them 0, one factor. Which should make the whole denominator 0. So x equals 2, let's try that. 2 plus 1, again, I'm just checking this. You can just check it directly into these. It's usually fine. But you do have to check it somehow. You don't have to necessarily physically show the work, but you do need to indicate this. because otherwise you may have an extraneous solution. So 2 plus 3, well, that gives you 2 plus 1 is 3, 2 plus 3 is 5, 3 times 5 is 15. So can you divide by 15? You can, but we can't divide by 0, so this is fine. So our only solution is x equals 2. All right, that concludes this lecture.